Hi, this is Tom Loschiavo, Chemistry Education Manager at PASCO Scientific, and I'm here today to introduce the PASCO Spectrometer. This is a visible spectrometer, and you'll notice from the box that there's a cuvette holder. The labels indicate the light sources that can illuminate your sample. There's a label over here indicating where the detector is. It can work via USB, via Bluetooth, and there's a power indicator. On the side, there's a USB port and a power button. I've already turned the spectrometer on, and I've connected it via Bluetooth to an iPad. And I did that through the Bluetooth settings using the spectrometer ID number, similar to the way we pair SparkLink Airs and AirLink 2s. Once I start the software, the spectrometry software on the iPad, then it'll also ask me to pair the spectrometer, and I'll do that the first time again using the ID number on the back. After I do that the first time, it'll recognize the spectrometer and it'll pair by itself. So let's dive in a little bit and see how we can use the spectrometer. If you look at the spectrometry software, you can analyze lights, you can analyze solutions, and you can do concentration and time analysis studies. To analyze lights, we're going to use the optional fiber optic accessory. So one end of the fiber optic accessory, you're going to point at a light source. In this case, I'm going to use some gas emission discharge tubes. And I'm going to use a clamp to hold it steady. The other end of the fiber optic accessory goes into the spectrometer. And the arrows are going to be pointing towards the detector. That tells you how to line up the cuvette. I'm going to put this in. It's a very snug fit so that it doesn't wobble around when you're doing your analysis. And I'm going to simply turn on my light source, make sure everything is lined up nicely, and hit start. I'll start recording my data. You'll notice a very tiny peak on here right now. It's because not enough light is getting in. So I can auto set the integration time to allow the maximum amount of light in while minimizing the amount of noise. And the software does that for you. So it will determine the best integration time, and it'll give you a progress bar to indicate how far along that process is. And after that process is complete, you'll see more peaks on your spectrum. You can auto scale that. And there's our hydrogen emission spectrum. I'm going to stop this and put another tube in just to show you something. I'm going to replace my hydrogen spectral tube with helium. Both these very common quick activities for physics and chemistry classes. I'm going to hit start again. Integration time should be pretty good based on the hydrogen. Now we have a different set of peaks based on the different emission lines for helium. I'm going to stop. And the software is built for you to do some comparison and analysis. So I can touch down here and I can overlay the two emission spectra on top of each other. Or if I'm looking at one of the spectral emission graphs, I can put some reference lines on there and see how well that matched up with what I expect to happen for helium. So there we have the expected peaks and the experimental peaks. And they're very close to each other, actually within a couple of percentage points. So that's analyzing light. The other common use for the spectrometer is going to be to analyze solutions, colored solutions like we have here. So the first thing we're going to do is we're going to go to the Analyze Solution page so we can get a full spectrum of a colored solution. And before I do anything, I'm going to need to blank the spectrometer. So I'm going to take my solvent, cuvette containing my solvent. I'm going to put it in so that the clear sides are facing the detector and the light source. Again, it'll be a nice snug fit. And I'm going to calibrate dark, meaning that the light in the spectrometer will be turned off. And I'm going to calibrate light. meaning that the light in the spectrometer is now turned on. And I'll go through a calibration procedure, again determining an integration time and setting the best calibration for you based on the solvent that you have. And if I hit start right now, then I should see an absorbance of 0 because I have successfully blanked this solvent. So now if I put some solutions in there where there are colored solutes, we should see a difference in the spectra. I'm going to wipe down my cuvettes to make sure there's no smudges. And there's a nickel 2 nitrate spectra. I'll stop that. And we'll put another one in. And start. And here is crystal violet. Now if you want to do more studies, which we'll show you in later videos, like concentration and time experiments, then you're going to want to set a wavelength to do those studies. To do that, you're going to use the coordinates tool. There's a tip over here in the tools section. Use the coordinate tool to set the solution's wavelength. Now touch the coordinate tool. Tool comes up. I'm going to drag it over to the area of the curve that I want to do my analysis on, typically the highest absorbance. And I'm going to hit the check button. And now I have a line indicating that that's where I'm going to do my analysis of the crystal violet in this case. And I'm going to stop. Now the other nice thing that you can do with solutions, without getting into Beer's law and kinetics, is you can do fluorescence very quickly and easily. The spectrometer itself has 2 LEDs for fluorescence, a 405 nanometer excitation wavelength and a 500 nanometer excitation wavelength for the fluorescence. So if I go to the fluorescence tab, it will turn on the light in the spectrometer simply by going to the tab. I'm going to put a fluorescing sample in here. I'm going to hit start. And my integration time was already pretty high. If it wasn't high enough, I could do auto set integration time again. It'll find the best integration time. And the nice thing about this, a neat thing to show, is that if I take the sample out, you can actually see the intensity of the fluorescing LED, the excitation LED at 405 nanometers. And when I put that back in, then you can see that that peak goes away because all that energy is getting absorbed. And now the sample is fluorescing in the 550 nanometer range. So we have nice, simple tools, very easy to get at the analysis, to do some analysis, to do experiments analyzing light and analyzing solutions using the fiber optic accessory and some cuvettes. And later on, we can talk about how you can do some Beer's law and kinetic studies using the PASCO spectrometer. Thank you very much. This has been Tom Loschiavo. If you have any questions or comments, let me know at chemistry@pasco.com.